Look, we don't see very often uh, questions based on combination of family of circles, parabola or family of parabola, ellipse, and so on and so forth. If you see the recent trends in JE paper, JE has already asked a question based on family of circles inside a circle, and with the basic ideas, there can be many beautiful and interesting problems which can be set for JE relevant topic based on parabola and circles. So here is one such problem. So we have a set of circles as you can see given by the equation and a fixed parabola y equals x square minus 1 by 4. Now the question is, suppose we have two circles from the set CA1 and CA2. So as clearly we can see, depending on value of A, we'll have a family of circles here. If we have two circles from this set CA such that CA intersection CA2 is empty, which means those two circles are completely disjoint and both of them touches the parabola. In fact, this thing you can prove by yourself as a statement. So this can be another statement of a JE problem as an option. They can ask you to prove, like you prove that CA1 and CA2 for any value of A1 and A2 they are going to touch the parabola, but in the problem I specifically mentioned. So if those two disjoint circles touches parabola internally such that the two transverse common tangent to them is mutually perpendicular. So I hope, so transverse common tangent are basically oblique tangents and direct common tangents are the tangents where center lie on the same side. Perpendicular. Now let's say CA3 with the circle passing through the 4 points of contact of the tangents above with center as h of CA3. Suppose further h be the point of intersection of those transverse tangent. So we have to find the characteristic point. So the first option is we have to check whether CA3 belongs to the circle set A. What I mean is whether CA3 is also the member of this circle family or it will be dressed up in the same fashion. Option B is CA3 is not belong to CA. Option C talks about CA3 cuts parabola in 4 concyclic points, and option D cuts parabola in 4 non-concyclic points. And the second part is we need to calculate the distance between point of intersection of transverse tangent, which according to passes I have named as H, and H of CA3. So you can try this question. It's a beautiful question based on a single parabola and different circles interacting on the parabola. It's a beautiful question based on a single parabola and family of circles which is hovering around this parabola. So here we go with the solutions. As you can see, the little bit if you investigate on the circle equation, it's better to take a particular value of A and to play with how circle looks like. So clearly if I take A as 0, we are going to get a point circle as you can see in the diagram. For A equals 1, we'll get x square plus y minus 1 whole square equals 1 and we'll have circle like something. For A equals some other value, maybe we'll get this circle, it might intersect. Okay, so just I'm giving you a rough peek of what's happening if A changes. So we can clearly see the circle starts growing along the positive direction of y-axis, and as you move further the radius of circles keeps on increasing. Now since the problem statement is already talking about for two circles which is touching the parabola, so we are tempted to check like for what value of A the circle system is going to touch the parabola. So just for the sake of simplicity I have played with x A equals 1. If we keep A equal to 1, so circle equation converts into this and we have a fixed parabola. After substituting for both value, we got a surprising result. The quadratic in y is having discrepant 0, which is a wow moment for us because now this circle is internally tangent to parabola for A equals 1. Now you might doubt like it might be internally tangent for all values of A, right? So you can give a try for maybe A equals 2 or A equal to A in general, and it's no wonder if you plug x square as y plus 1 by 4 even in this general equation, you'll get D equals 0, which shows that independent of value of A, all these circles is internally tangent to parabola. So what it means, like if we have parabola like this, clearly at x equals 0 we have minus 1 by 4. So all these family of circles behaves more or less like that. Right? So all these families are basically the envelope of this circles is parabola. So all these circle family are tangent to this parabola. So this is a gross pictures of this problem, and that's quite beautiful thing about this. Now next is a usual calculation. So I've taken two disjoint circle such that the perpendicular transverse tangent, as you can see, is marked like this, is A dash and B dash. And since the point of intersection 90 according to the problem, so let the center of the circle C1 I call 0 comma A1 with the radius root A1, and center of circle C2 is 0 comma A2 with radius root A2. Now it's quite easy to check, like C1H is going to be root 2A1 because from the symmetricity of the axis of the parabola, the angle at H which I have shown C1 HA is going to be 45 degree, and so is the other angle. So that gives you C1H distance as root A1 by cos 45, which is root 2A1, and we have C2H as root 2 A2. So root 2 into root A1 because root A1 is the radius, and root 2 into root A2. It also helps you to find the coordinate of point A, which is not a very difficult task because from A if I drop perpendicular, this distance is known as A1 by root 2. It's root A1 by root 2, and the other distance is A1 plus the y coordinate is A1, which is distance from the origin, and plus this extra distance is root A1 by root 2. Similarly, we have B equals root A2 by root 2 and A2 minus root A2 by root 2. So, and which is equal to root 2A1 plus root 2A2. Which you can see in the diagram because root 2A1 is basically HC2, root 2A1 is SC1 and root 2A2 is SC2. So using this we know the value of C1, C2 because from here we get a relation between A2 and A1 that can be written as root A2 minus root A1 equals root 2, as root A1 plus root A2 will cancel. Now we need to find a circle passing through these 4 points A, B, A dash and B dash. Clearly its center is not going to be H because the distance of H from A is root 2A1 and distance of H from that other circle is root 2A2. And since A1 is not equal to A2, because as you are moving above, the distance of center is changing, hence A1 and A2 are different. So H is not an equal distance from the both circle. So the center of the circle containing A, B, A dash, B dash is going to be somewhere else. Of course, from the symmetricity, it will be definitely on the y-axis. So that let's call that is 0 comma alpha. Now, if you do the calculation part, which I am leaving up to you, you will get alpha in terms of A1. Because basically now just I can equate the distance. Let's say 0 comma alpha distance from point B and 0 comma alpha distance from point A. So we have point B coordinate given, point A coordinate known. So I'll equate this distance, I'll be getting the value of alpha in terms of A1 and A2. And A2 and A1 is already related. So just little calculation will show you alpha value is going to be A1 plus 1 plus root 2 A2. Now the most interesting point that you are seeing here, the equation of the circle passing through A, B, A dash and B dash is having center at 0 comma some point alpha, and the radius is actually going to be root A, because that's really surprising. What surprised you is alpha equals A1 plus root 2A1. So the third circle CA3 is also a member of the same circle family, which can be directly proven by putting it in the same structure, because center is already known and radius you can clearly find the value of H and B, like center 2B, and that gives a very exciting result, because once we know H and C of HA3, so once you know the value of H, and the coordinate of circle A3 center, so this distance is nothing but simply you can check. In fact, you can show it for a general parabola, like the distance is twice of the distance of focus from the diatrix. So here diatrix of this parabola is going to be somewhere here. Focus is origin here, in this case 0 comma 0 behaves like a focus. This is basically twice of this distance. This distance is half, hence the distance between the center of that circle passing through the point of contact and the point of transverse tangent intersection will be exactly twice of distance of focus and diatrix. That's really surprising result. I hope you must have enjoyed. Instead of parabola, we could have kept even ellipse and can make an interesting problem. Even you can play and create a problems based on hyperbola like this. So this is a fertile ground from where you can possibly ask many questions on basics. I hope you enjoyed the problem. Until then, bye bye.